Hello and welcome to this module on critical path calculation. In this module, I'm going to be taking us through what critical path method is, what critical path is, as well as looking at a few examples on how to calculate the critical path for project activities, as well as slack, and also to look at some questions that typically you would have in the PMP certification exam. Here are a few characteristics of the critical path. It is the longest path on a network diagram, and typically you draw your network diagram as an interrelationship of activities on a project. We had earlier talked about how to draw or how to construct the network diagram. You move from left to right. It shows the relationship between activities in a project, and the critical path has no slack. There can be multiple critical paths. Typically, when you draw the network diagram showing how you progress from the start of a project to the end of that project, you would usually have multiple paths leading from the start of the project to the end of the project. There would be at least one of those paths that will be considered critical. Okay, so that is the critical path, and these are the characteristics that define that path. However, you can have more than one of such paths that meet these characteristics. So it is the longest path on the network. It has no slack. Slack, as we had earlier talked about, and as we'll talk about on the next slide, is opportunity for delay. So when we say no slack, it means there is no opportunity for delay. Slack is also known as float. The greatest project risk usually occurs on this critical path or on this path, and that is because on the critical path there is no opportunity for delay, there is no allowance for there to be any mistakes. So because such is the case for the critical path, there is a high level of risk associated with it, because once there is any mistake or any error or any issues associated with that path, then the overall project finish date will be delayed, or the project will be delayed in some way. And you do know the concept of triple constraint. Once there is a delay or a change or some issues with one of your constraints, there is a great potential that it would affect other areas of the project as well. So it's important that a lot of effort and a lot of attention is paid to critical path activities. The last of the characteristics of the critical path activities, or the critical path I would look at, is that a slip on the critical path causes the overall project finish date to slip or to delay, just like we had said earlier. Because slack is one of the defining characteristics of the critical path, it's important to understand the concept of slack, otherwise known as float. It is the amount of time that an activity can be delayed without it delaying the finish date of the project, or that of the activity, or that is the activities next to it, or the published project completion date. Slack, as you would have realized, is measured in time. Okay, that is in terms of weeks or days or months. It is calculated using a forward and backward pass, which is one of the concepts that we're going to learn in this model. Slack, otherwise known as float, can be negative or positive. It is negative when the project is behind schedule. At that time, slack can become negative, but ordinarily it will be positive. There are three types of slack. There's the free slack, there's the total slack, and there's the project slack. Free slack involves determining the latest an activity can start without delaying the activities that follow it. This means that free slack is based on the relationship between activities within the project. So it talks about the amount of time that activity A can be delayed without impacting on the start time or on activity B that probably follows it. Then there's total slack, which is the latest an activity can start without delaying the project finish date. So that has to do with the amount of time that is available, or the amount of time can that can be wasted, if you like, without it impacting on the overall project finish date. And then there is project slack, which is the amount of time an activity can be delayed without it delaying the published finish date. So that already suggests to you that there could be a difference between the project finish date and the published finish date. Typically, the project manager and his team can decide to have a different date to finish the project that is published, that is made known to other parties outside of the team. While they may be working with a slimmer schedule, they may have given the other stakeholders outside of the team a schedule that has some buffer, okay, to allow them have some leeway as per when to complete the project. So there is a slack that can impact on the project finish date, and there is slack that can go beyond the project finish date and even impact on the published finish date of the project. Here is an example that shows how to calculate the critical path. I have here a table that shows activities and the durations, and then the relationship between the activities on the project is explained here, where we have when the project starts, activities A and B can begin. When activity A is done, activity C can begin. When activity B is done, activity D can begin. Activity C and D must finish before activity E can begin. Activity F can begin when activity D is completed. Activity G can begin when activities E and F are completed. And when activity G is done, the project is finished. The durations are shown in the table as earlier stated. In the next slide, I will be drawing the network diagram and would attempt to answer the question, what is the critical path in that network diagram, and the duration of the critical path as well as the duration of the project. So when the project starts, activities A and B can begin. Activity A has a duration of 4 days, activity B 5 days. Then activity C follows activity A with 4 days as well. Activity D follows activity B. When activities C and D are done, activity E can begin with a duration of 8 days. Then after activity D, activity F can begin. Once activities E and F are done, then activity G can begin, and once activity G is done, then the project is finished. So this is a network diagram, and if you look through this network diagram, you will see that there are 3 different paths. That is how you can move from start to finish. Okay, so you can use the letters to define the paths by saying path A, C, E, G is one path. Then you can also go path B, D, E, G, and then you can also have path B, D, F, G. So that's A, C, E, G, okay? B, D, E, G, that's another path that you can go from start to finish. And then B, D, F, G. of these three parts, one of them at least is the critical path. And like we had said, the critical path is the longest path on a network diagram for a project. So when you look at this critically, you will find that the critical path is actually ACEG. ACEG, and that is because it is the longest path and the duration of that path is actually 21 days. So the duration of the critical path is 21 days, and the critical path duration also determines the duration of the project. So the duration of this project actually is also 21 days. So this is a simple way by which you can find critical path for a project using the network diagram. However, oftentimes your project activities will be much more than this, and the network diagram will be more complicated than this. And so a better way to actually draw the network diagram and be able to not just find the critical path, but also to be able to determine which activities have float on them. Remember the concept of float, opportunity for delay, and whether you have multiple critical paths and so on and so forth. A better way to do this is to utilize the forward and backward pass method, and that's what we're going to be looking at in the next few slides. The critical path method that utilizes the backward and forward pass is used with scheduling environments where a forward pass is used to establish the earliest the activities can start and finish. Backward pass is used to establish the latest the activities can start and finish. It also allows for the calculation of the critical path and the amount of slack on each activity. Any activity on the critical path has zero slack, and you see how this plays out as we go on. A negative slack is possible, as I mentioned earlier on, if the project is behind schedule, and the project manager typically would have his or her eyes on critical path activities because on those activities you have the highest amount of risk because of the likelihood of things going wrong on those activities, and because you do not have any allowance for slippage or for errors or for mistakes on those activities that are on the critical path. So the forward and backward pass calculation is used to determine critical path of the network diagram. It shows how much slack or float there is for each activity, which in the earlier method that I showed us did not have that. It shows how much total slack is on the network. The activities typically will be represented by early start date, ES, which is the earliest an activity can start, early finish date, the earliest an activity can finish, late start date, which is the latest an activity can start, late finish date, which is the latest an activity can finish, also by the duration of the activity, which is the length of the activity, as well as the slack, which is the number of days, usually in time unit, which the activity can delay without affecting other activities or the project finish date. In using the forward and backward pass calculation, here is the summary of how each box will look like. Unlike the earlier method that I showed, where all we had was just a box representing the activity and with a nomenclature which was maybe activity A or B or C and the duration of the activity. In the forward and backward pass calculation, each activity will be represented by its early start, ES, the duration, the early finish, the late start, the late finish, as well as the slack as shown in this diagram. I'll run us quickly through the steps for the forward pass as well as the backward pass calculation, and then I'll take us through two sample exercises. Step 1 for the forward pass is you set the ES, that is the early start of the first activity or activity A, or if you have a scenario where there are two or more activities starting together at the beginning of the project, then you set the ES, that is the early start for all of those activities, to 0. Step 2 is that you add the duration per each activity to its early start to get the early finish. Remember that when you are going through the forward pass calculation, or you're doing the forward pass calculation, you will be filling the top row for each of the boxes of the activities. You'll be filling just the early start, the duration, as well as the early finish. And you do that from left to right up until the end of all of the activities. This I'll show you when we look through the exercises. So furthermore, in step 2, at a convergence, we'll see examples of convergences when we do the exercises. You select the larger of the early finish dates and continue the process. Step 3, as you move from an activity to the other, that is from activity A to B or B to C, as the case may be, set the early finish, that's EF, of the current activity to the ES, or to B, the ES, that's the early start of the next activity. These steps you will repeat for all of the activities up until the end. Remember, you're filling the top row from left to right, from the beginning of the project to the end of the project. For the backward pass calculation, you will be filling the bottom row from the right, that is from the last activity coming back to the first activity, filling the bottom row. So here you have the steps. The latest finish, that's LF, becomes the same as the early finish on the last activity, also the duration of the critical path. Step 2, you subtract the duration per each activity from its late finish to get its late start. Late finish to get its late start. At a burst, and I'm going to show us a burst, select the smaller of the late start dates and continue the process. Step 3, as you move from an activity to the other, set the LS of the current activity as the LF of the next activity. Remember, when you're carrying out the backward pass calculation, you're moving from right to left, from the end of the project to the beginning. Repeat the steps above for all activities up until the end. So here we have the same example that we did earlier on, where we got the critical path to be 21 and the critical path to be ACEG, and the critical path duration to be 21. So here we have the same question, and I would attempt to solve it using the forward and backward pass method. Here we have the critical path calculation for the earlier example using the forward and backward pass method. So project starts, activities A and B start, and you can see now I'm using the forward and backward pass activity box as earlier shown for the activities now. Once activity A is done, activity C starts, then activity B is followed by activity D, and then activity E follows activities C and D. Then activity F follows activity D, and once activities E and F are done, then activity G, and once activity G is done, then the project ends. So here you have the activities on the figures on the top row represent what is done in the forward pass. So if you look through the diagram, you will see that the figures on the top row are in white. All of those figures are what you fill in the forward pass method or the forward pass process. And you see that the first step says set the early start of the starting activities. In this case, activities A and B are the starting activities. Set the early start to 0. So that's why you see on the top left corner 0 for activity A and B. The duration comes next, which is in the top middle. So for activity A, duration is 4. For activity B, duration is 5. So the next step is to add the duration to the early start to get the early finish. So 0 plus 4 gives you 4, which is on the top right corner, and 0 plus 5 gives you 5. So those are the first two steps. And then the next step says that as you move from one activity to the other, set the early start of the next activity. In this case, C is next to A. Set the early start of C to the early finish of A. So that's why you have 4 in the top left corner of C and 5 in the top left corner of D, which follows after B. Okay, so that is the next step. And so you now continue the steps. That is 4 plus 4, that's early start plus duration, gives you early finish for C, which is 8. Early start plus duration, that's 5 plus 2 gives 7. And then you move on to the next step. And the next step is you move from C to E and D to F. But there is now a situation, which is what we call a convergence. You can see that C and D impute into E. C and D impute into E. So that is a convergence. So the challenge is, which early finish would you set? Which of the early finish, is it the early finish of C or of D that you will set as the early start of E? So what you have there is a convergence, and at the convergence, what do? You pick the larger or the largest of the early finish. So in this case, between C and D, the larger early finish is 8. So for E, the early start becomes the larger early finish between C and D, which is 8. And so 8 plus 8 gives you 16. For F, however, it is only D that is imputing into F. So you pick the early, the early finish rather of D, and you make it the early start of F, which is 7. 7 plus 2 gives you 9. And then between E and F going into G, that is also a convergence. You pick the larger, which is 16. So 16 plus 5 gives you 21. And so the earliest finish for G is 21. So that is the earliest the project can finish, which is G. So you have completed your forward pass in that motion. You've completed the forward pass and you have 21 as the early finish, which is actually also the duration of the project. So you come to the lower rows and you start your backward pass from the right to the end. And so in carrying out the backward pass, you set the early finish as the late finish in the last activity. So you set 21, which is early finish, as the late finish, okay, on the bottom right hand box to 21 as well. And then you start the process. You minus the duration, which is 5 from 21 to get to give you the late start, which in this case is 16. Then you move to the next. In the next, you have G imputing now into E and F. Remember, we're going now from right to left, so we're going back. So G is imputing into E and F. So you set the late finish of E and F to the late start of G, which is 16. So you see 16 on both sides, and then you minus duration, that is 8 for E. 16 minus 8 gives you 8. For F, 16 minus 2 gives you 14. And then from E and F, you move to D. To move to D from E and F, you need to consider which of the late starts, okay, of F or E would you pick for D, because E and F input into D when you're looking at it from the right to the left. Okay, so in this situation, we have a burst. According to the steps we earlier highlighted, if you have a burst, you would pick the smaller of the late start values. So in this case, we have 8 and 14, 8 from E, 14 from F. So which late start would we have for D? So you will pick 8 to become the late finish for D. Okay, so it's 8 there, and then only E inputs into C, so it becomes 8 as well. 8 minus 4 for C gives you 4 for the late start for C. 8 minus 2 for D gives you 6. And then you go on from D to B, you have the late start becoming the late finish for B. That's late start for D becoming the late finish for B, okay, which is 6. And then 6 minus 5 is 1. And then late start for C, which is 4, becomes the late finish for A, which is 4. 4 minus 4 gives you 0. So there you have the forward and backward pass method showing the completed critical path calculation. And so you find that for you to know the slack for each of the activities, you could either do late start minus early start or late finish minus early finish. In this case, for A, late start is 0, late finish is 0, late start is late start is 0, early start is 0, late finish is 0, is 4 rather, early finish is 4, and when you minus that, you have 0, and so you have your slack as 0 there in yellow. Okay, the same way if you look at B, late start is 1, early start is 0, late finish is 6, early finish rather is 5, and that gives you 1 if you when you do the subtraction. So, and you have 1 in yellow. So when you look through all of these boxes, the boxes that have slack as yellow or slack in yellow as 0 are the activities on the critical path, and that gives you A, C, E, G. So that gives you the critical path activities. The last number at the end, that is the early finish as well as the late finish, is 21 in this case, and that gives you the critical path, rather the duration of the project, as you can see, and that is the duration of the project, and that also is the duration of the critical path. Now, what this does and why this is different from the earlier calculation is that this gives you at a glance key elements of the schedule. Basically, it gives you the free float or the free slack for each of the activities. It helps you to quickly see where things may be going wrong on the project. It helps you to immediately see the activities that are on the critical path and the entire critical path, and it helps you to move things around much easier than the earlier method.